Hello everyone. So welcome to another video about software exploitation. In this video, what we will be doing is going over how to find the bad characters in the application. So when we generate our shellcode, we can avoid them. Now, one thing to keep, or a couple of things to keep in mind when we say bad characters, they are really not bad characters. They just mean something differently to the application. So let's say if an application takes, like here, when if I on my screen, when I type the enter, so that carriage return and new line feed, that will be understood by the application differently when you enter it as a value in your shellcode. So the application might terminate that. Let's say it might terminate the shellcode because of it, and that depends on the type of application you are dealing with. Similar to, let's say, in an HTTP, you can see in an HTTP request. Let's say if we have, because we'll see later in the course, when we deal with, let's say, a web application server and we want to exploit it, you can see that if you are going to send HTTP requests, you are going to, like, let's say, you're going to forward them manually and you're going to send them through your code. So at the end, you'll have that carriage return new line feed /r/n. Those sent to the application understands them differently. But when they are in the application's memory, they might break our shellcode because uh, depending on how the application will deal with them. So bad characters could, like a character could be bad for one application. That doesn't mean it's going to be universal. But I would say most applications that deal with strings have, like, the space, the null value. Those are going to be considered bad characters. Most, I would say, applications that deal with that. So you should keep that in mind. But anyway, how do we find those bad characters? That's what this video is all about. If we just go back to our basic application, we had, if we send 20 A's and then 4 B's, we can overwrite EIP. We just want to control, make sure we can control it. So I'm just going to do that, and then I will add, show how we are going to use our bad character thing. So you can see the 4Bs got overwritten in EIP. So everything looks good. What we are going to do is going to do finding those bad characters using two methods. One using Mona, which is not in this video, and one using the manual method. Okay, so one thing to start with is we want to generate uh, the set of ASCII characters in hexadecimal, which are 256 characters. So we want to generate them. So if we go to Mona, okay, and then you can say byte array. So if you just say Mona, then say byte array, okay, and just hit enter. Now it will create this byte array for you. So see this is a byte array. And if we go to our directory, let's go to the directory. That's all I needed now. And you can see done wrote 256 of bytes into the byte array.txt, and it also stored it in a byte array.bin. We'll come back to this one in the next video. In this video, let's use the manual method, which is a little bit, it's a long process, but at least to understand the idea. So let's close this and update our code. So we can go here, get the byte array. Okay, so we can do this, copy it. So let's call this byte array equal, let's just call it bytes, or actually let's call it bad character, yeah. Badchars equal this. Okay, we can already immediately delete the zeros because we already know that's a bad character. So we can immediately remove that and save. And now we don't need this anymore. And run the code again. But let's add it here. So we'll do add Badchars at the end so we can track them in memory. So if we run this, okay, and we can see our, do we add the payload? Add Badchars. So yeah, we did. And then the length of the buffer. Okay. So if we come here and now run the application, okay. So the application, it seems it didn't crash successfully. So if we look here, let's look at here. So we have our 20 bytes of A's, right? Or how many were they? Yeah, 1, 2, 3, 4, 5. Yeah, 20 bytes of A, and then we have the B's, and then we have 1, 2. Let's see if we can follow this in the. We can. Is there anything pointing to them? No problem. Let's just watch them and follow them here. So 41, 41, those are our A's at the beginning of the code. If we go back here, those are the A's, 21, 20 of them, I mean. And then 4 B's, these, and then our bad characters. Okay, so now if we go to the bad characters, we have 1, 2, 3, 4, 5, 6, 7, 8, and then see we don't have a 9. So what that means is probably 9 is a bad character, and that's why the values got truncated. See, the values after that got truncated. So what we'll do now is we'll remove the number 9. So we'll add, we can do this. So you can say Badchars equal, let's do this x00, and now we have the 09. Okay, so these are bad characters. Let's run our code again and see if we have any other bad characters. So it seems there is also some other things going on. Again, let's run the code F9, and let's go to the stack, see where our bytes got stored on the stack. So again, we see the A's, all good. We see the B's, 1, 2, 3, 4, 5, 6, 7, 8, and then 0A, 0B, 0C, 0D, 0E, 0F, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19, and then we have 1A, 1B, 1C, 1D, 1E, 1F. So 1F, and then after that, the values got truncated. So let's go back here to our code and see what's after 1F. So if we go back here, 1B, right? If we go here and see 1D, 1E, 1F, so we can see that 20 was a bad character, and 20, I think it's the space. So if we remove that now, put them over here and run the code again. So we now found 3 bad characters. And let's run the code again. 277. Okay, seems we have another bad character probably. Run the code, and we can see the A's again. Okay, the B's, then we have 1, 2, 3, 4, 5, 6, 7, 8, A, B, C, D. All of that is 12. All that is okay. 1A, 1B, 1C, 1D, 1E, 1F, 2, 0. 2, 0, we deleted that. Then we have 2, 1, 2, 3. So where is 2, 2? Probably that one is also a bad character. So again, let's remove it because it doesn't seem to be working correctly. And so let's remove this one and add it over here, 0x22, and let's run our code again. So if we run the code again, let's see what's gonna happen. So now if we hit F9, okay, so we have one, all of this is good. All of this is, so we have 08, 09 we deleted. Okay, so 1, 1, we have 1A, 1B, 1C, 1D, 1E, 1F, 2, 1, 23, 24, 25, 26, 27, 28, 29, 2A, 2B, 2C, 2D, 2E, 2F, 30, 31, 32, 33, 4, 5, 6, 7, 8, 9, 3A, 3B, 3C, 3D, 3E, 3F. We continue 40, 41. I'm gonna just like try to 45, 46, 47, 48, 49, B4, C4, D4, E4, F, and then 50, 51, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5, 7, 5, 8, 5, 9, 5, 5, 9, 5A, 5B, 5C, 5D, okay, 60, 61, 63, 64, all good, 68, all good here, 66C, I mean 60, 6E, 6F, 70, all seems good here. Then we have 79, 7A, 7B, 7C, all 80. We have everything over here is good. So it seems until now, by the way, seems until now, 38, 83, 84, 85, 86, 87, 88, 89, 80. Okay, if we just go through them, 98, 99. So you can see that we are checking them manually. It's a long process, that's true, but A0, A1, A2, A3, A4, A5, A6, A7, A8, 9, AA, AB, AC. Okay, I don't really see any bad characters in this, and I see the values have not been truncated. But what we have here, by the way, is our values FB, FA, FB. So if we look here where FA and FB are, so FA and FB, we can't seem to find the other ones. So FC, these are not available. We couldn't see them. And the reason why is the buffer. If you look, go back here, there is no longer any more space left in here. So what we could do, by the way, to test those as well, is we could probably just add them at the beginning. So that's what I'm going to do now and test if that will break anything. So it seems there is no bad character anymore in here. Everything looks good, by the way. So let's close this and just take these 4 bytes, okay, and add them maybe at the beginning. So we'll have 16, right? And then we'll have these 4 bytes, and then we'll have the B's and then the bad characters, just to make sure that there is no bad character in any one of these. So if we do, if in your program there's a syntax error, what did I do wrong? Oh, we don't have the, okay, great. So if we restart everything here, okay, and then run the code, we just want to see if it got manipulated in memory. So we can see the A's, and then you can see FC, FD, FE, FF. So nothing got really manipulated. So it's clear that these bytes are not bad characters. So that means our bad characters for this application is 00, 09, 20, and 22. Those are the bad characters for this application. Okay, so let's now when you generate your, like, let's say shellcode, yeah, now when you generate your shellcode, you just need to avoid these 4 bytes, because for this application these 4 bytes are bad characters. Okay, so that's it for this video. Okay, we just wanted to see those values if they get manipulated in memory, because if there is a bad value, it will truncate the shellcode. So if this was a part of the shellcode, then it will truncate that, because of it will get truncated because of the bad values, the bad characters in there. Okay, so all you need to do is pay attention to what byte got, let's say, modified in memory. Once it was injected in memory, which one of those bytes got, let's say, modified in memory, then you'll need to remove that and test again. If you find another one, remove it, test again until you find all the bad characters. Okay, so it's a long process, but at the end, you can find the bad characters this way. Okay, so again, that's it for this video. In the next one, we'll see how to find that, but depending on Mona for helping us making things a little bit more quicker than the manual method that I did now in this video. Thank you and see you in the next video.